Okay, hi everyone. Just doing a couple of tests before we start. Can you hear me? Can you maybe type something on? Is it possible to type some messages in the chat window so that I can see that actually you can hear me? Okay, thanks. It seems that you can hear me. So let's, it seems that everything is fine. So let's wait for a couple of minutes and we will start in, let's say, 5 minutes to give some times to maybe other friends to join this quick training. See you in 5 minutes. Okay, we will start at 10 when we have at least 10 people. I see that for the moment there were only between 6, 7, sometimes 9 or maybe 10 attendees. Um, let's wait to be at least 10 before we can start, just to be efficient. And we are 10, so I suggest we start, and then all the other people will join whenever they can. So, hi everyone, my name is Gabor. I'm located in France, in Paris. I hope that you can hear me well. If you have any issues during the presentation, please drop some lines in the chat window so that I can help you out if necessary. We wanted to do this opportunity. We wanted to take this opportunity and to have a quick introduction to the LoRaWAN technology during 50 minutes to 1 hour. The purpose, of course, is to prepare the hackathon for next week. As you might know, Orange really wants to stress out the importance of the LoRa technology during the hackathon. So we want to be sure that everyone is as up to date as possible on this technology. Obviously, you don't have to become experts, but my purpose here is to give you a high-level introduction to the LoRaWAN technology, and maybe answer some of your questions at the end of the presentation. Of course, if you will have questions after the presentation, you can still ask me directly on Slack, and I will be happy to help you out. Maybe just a couple of words about the company I work for, Activity. You've probably seen that Activity will attend the hackathon and will be part of the teams. So Activity is a French company based in Paris that provides LoRaWAN networks and LoRaWAN network management solutions to operators such as Orange, but also Comcast in the US, Proximus in Belgium, SoftBank, and Entity in Japan. Basically, Activity is behind almost all the major LoRaWAN deployments in the world. Okay, so we are like we are considered as the experts in the LoRaWAN technology today in the world. We already raised more than 100 million euros as total funding so not 33 as mentioned on the slide. We secured a couple of months ago a 65 million euro funding, and Orange is also part of our investors. So we are now, we are in another dimension as a company. We are growing very quickly, and we are basically deploying LoRaWAN networks a little bit everywhere in the world, and this is probably why us to attend this hackathon and to help you out, guys, on anything that is LoRaWAN related. So this is about activity. Maybe just a couple of words about myself. I'm in charge of the solution marketing, so the LoRaWAN solution marketing. It's one of my jobs, and I'm also doing business development on some specific verticals, such as utilities, smart cities, tracking and logistics, the connected manufacturing plants. So basically, I'm working with many companies on these verticals to architecture and to propose complete end-to-end IoT solutions based on the LoRaWAN technology. I'm also both engineer but also commercial guy, so I have like a double head. So that's about myself and activity. Let's jump into the details of the technology. So the first question that you might ask is, why are we talking yet about another IoT technology? I'm sure that you are already familiar with many IoT technologies such as Wi-Fi, Bluetooth or Bluetooth Low Energy, maybe Sigfox, maybe the 3G, 4G cellular technologies. You might have heard about other technologies such as Zigbee, Thread, or Z-Wave. So there are many technologies, IoT technologies, already available on the market. So the first question is, why do we need a technology such as LoRa in the IoT landscape? And the answer is quite simple. Until today, many of the existing IoT technologies are able to send data over a short distance. This is the case for Wi-Fi, Bluetooth, Z-Wave, Zigbee, all these well-known technologies. They are all able to communicate over short distances. By short distances, we are talking about a couple of dozens of centimeters up to a couple of dozens of meters. So these are great. But if you want to send data over a very long distance, if you want a solution where you don't have all kind of local gateways or repeaters or stuff like this, solutions are not the best way to go. Another solution is everything that is cellular based, but you know that cellular is 3G, 4G is quite expensive. Of course, it's long range, it's high data rate, but it's quite expensive and not everyone can use it. You have to buy SIM cards, you have to buy connectivities. So it's not something that is very useful when you have a huge volume of devices that you want to deploy. There are other technologies such as satellite-based technologies, but these are very expensive. Of course, the advantage of this solution is that it can provide coverage a little bit everywhere on the planet, even in the middle of the ocean or in the middle of Sahara. But it's very expensive because it's based on satellites. And of course, you can still have a wired-based connectivity, but yeah, it's not the future. If you want to deploy billions and billions of connected objects, wired solutions are not the best way to go. Otherwise, you will need huge amounts of cables, and it's probably not the best way to go. That there was a missing link. There was a technology missing that could ensure that the device is able to communicate over a very long distance, such as cellular, for example. So you needed something that can communicate over 10, maybe 20 kilometers, but in the same time, something that could be very interesting for the battery consumption. If you have a mobile phone, like probably everyone on the planet right now, you probably have to recharge your battery every day or every other day. The reason for this is that the cellular connectivity is very heavy on the battery consumption. If you need something that is very interesting from a battery consumption perspective, cellular is not the best way to go. So we needed something that is able to communicate over a very long distance, but in the same time consume only a very small amount of battery. You can see on this slide that actually there was this missing link, so battery life very high and range very high. And this is where LoRaWAN, plus a couple of other technologies you might heard of, like Sigfox or NB-IoT. So this is the part where all these technologies are currently playing. So LoRaWAN is a new IoT technology. It was invented a couple of years ago, and it's an IoT technology that allows to send data over a very long distance, of kilometers, and at the same time consume very little power. So we are talking about a technology that is able to provide batteries that can last several years and maybe more than 10 years in some scenarios. So interesting to enable many use cases that we were not able to address before because we had nothing that was able to ensure that the battery life is excellent, or we had nothing that was able to ensure that the coverage and the communication range was very good. And as you can see, many studies, many market studies out there tend to show that what we call the low power wide area network market segment, will have a huge market share in the coming years. And we are talking about billions and billions of connected devices right now on the market. So again, LoRaWAN, it's a new technology. But it's a very interesting technology, so many people are currently using it. Many operators in the world are currently deploying LoRaWAN networks on a national level. So it's really one of the most interesting and the most disruptive technologies currently available on the market. And this is why we encourage people to test as much as possible and to develop new use cases, new solutions based on this technology. So I hope that this allows you to understand why LoRaWAN is an interesting solution. Now, if we deep dive a little bit more in the architecture, this is the basic architecture of a LoRaWAN network. So you have gateways. So it's a bit like in the cellular network. So you have gateways or base stations that are deployed a little bit everywhere to cover a huge country. And basically all these gateways provide the LoRaWAN connectivity. Okay. The advantage of this versus cellular is that LoRaWAN has a 2 to 3 times the range of the cellular connectivity. So if you want to cover the same area, you will need 2 to 3 times less gateways to cover the same area than in cellular. For example, in France, Orange, a network of 4,000 gateways, 4,000 base stations, and this is enough to cover all the country. I know that Romania has more or less the same size, so we would probably need more or less the same kind of amount of base stations or gateways to cover the country. Now, all the base stations, they are connected to a basic internet, so the same internet that you and I are using every day. So it's a basic IP connection. They can be connected through Wi-Fi or Ethernet or cellular backhaul or satellite connectivity. And all the base stations are connected to what we call the brain of the network, which is the core network server. So the core network server, as I mentioned, is a little bit the brain of the network, who is managing everything: uplinks, downlinks, security, the network management, the gateway management, the device provisioning, the connectivity plans, the routing of the data. So basically, the core network server is doing everything. Mandatory, and it's the most important brick, the most important component in the LoRaWAN network server. And this is the product that Actility provides, for example. Okay, so this is the product that we provide to Orange. This is the product that we provide to Comcast, to Entity Docomo, to many operators in the world. Today, this is what we've sold to more than 30 or 40 big operators in the world. And the network server is also in charge of exposing the data that is arriving from the device to an end user's application. Okay, depending on what the use case is, sometimes you can have a mobile application, sometimes you can have a SCADA system, sometimes you can have a website. So the network server is in charge of routing the data from the devices to the right and to the relevant application server. Okay, so quite simple architecture. Devices are sending data to the gateways. Gateways are connected to the internet, through the internet to our network server, and our network server is sending the relevant data to the end user's application. Okay. LoRaWAN as a technology, it's very important. It's a bidirectional technology, which means that you can receive data from an end node or an other sensor, but you can also send data. And this is very important because it means that you can enable use cases such as switching on or off a light, switching on or switching off air conditioning system, or a motor, or anything you can think of, you know. And so this is a very powerful feature of the technology. So it can manage the data in both directions. In the same time, one of the most important things that you have to understand is that, yes, it allows to send data over a long distance. Yes, it allows a very interesting battery life, but it's a low data rate technology. Okay, so LoRaWAN is not meant to send video, to send music or audio, or to send pictures. It's a very low data rate technology. We are talking about data rates from 300 bits per second up to 5.5 kilobits per second. So it's very, very, very slow. Again, this is not meant to do everything. It's not meant for high data rate or streaming. However, for everything that is sensor related to telemetry related, it's perfect because it's largely enough to send small amounts of data 10 times a day, 50 times a day, 100 times a day from a sensor to a centralized network. You don't need high data rate, you don't need megabyte kind of connection to send small amounts of payloads like a temperature or air quality level or GPS position. You don't need high data rate for this. So the low data rate that is proposed by the LoRaWAN technology is largely enough. So again, very simple architecture. It's easy to deploy. It's not so expensive because the base stations cost between 500 and 2,000 euros. So compared to the cellular eNode Bs or cellular base stations, it's very cheap. The core network server can be in the cloud or on premises, so it's easy to deploy, easy to operate. It's a very straightforward and very easy to deploy solution. So that's why all the operators are currently deploying it, because you don't need a huge amount of infrastructure to propose this kind of IoT-based LoRaWAN network. Another interesting feature about the technology is that the standard is open. Okay, so you don't have to pay to use this technology. All the network standard is completely open sourced. Anyone can use it, anyone can implement it, which means that Orange as an operator can deploy a network, but as a person, you want to deploy a LoRaWAN network in your garden, you can also do it. You don't, so I shouldn't say this in front of Orange people, but basically anyone can deploy and operate a LoRaWAN network. You don't need a specific license. You don't need to pay any kind of fees. It's a completely open sourced and free technology. Okay, that's why there is a huge alliance. Okay, full screen. Sure, I can do this. I hope that it is better. Because it's an open standard, there is a huge alliance that was created around this technology. Today, this standard is managed by an entity called the LoRa Alliance, and there are more than 500 members. This slide is a little bit outdated, but now there are more than 500 members that are in this alliance. This alliance has been created 2 years ago, and Activity was part of the 3 companies that created this alliance. So this is to let you know how good we are, of course, in this technology. Just joking, but there is a huge ecosystem now around this technology. There are many operators that are part of this alliance, that are huge industrial players: Bosch, Microchip, Inmarsat, Schneider, ABB. There are plus many other security players: Gemalto, Atos, Multitech, Cisco. So there are also many device makers. So there is a huge ecosystem now that is managing this technology, and this is great because it means that case you want to address, there are already companies proposing sensors or actuators to cover this use cases in this LoRaWAN technology. So it's probably today the fastest growing technology alliance in the world, and it's very exciting for us to be part of this adventure. Okay, just skipping some slides. This is for your culture. Many countries are currently deploying the LoRaWAN standard, and the beauty of the thing is that because it's a common standard, it means that all these networks are completely interoperable. So in a couple of years, we will probably have like a complete virtual coverage of the planet in this LoRaWAN technology, and your device will be able to go from one country to another and to roam from one network to another, like in cellular today. In a couple of years, it's going to be completely transparent for us. So many networks currently rolling out networks. Of course, Orange is part of this. They are deploying one of the biggest networks currently in France. As I mentioned, more than 4,000 gateways already deployed. I will skip on the technical details. I can ask some more specific questions at the end. I just wanted to jump quickly to this slide. LoRaWAN, it's not only an open standard, it's also a technology that is not using license spectrum. Okay, so basically you don't have to pay for the frequencies in order to operate a LoRaWAN technology. The LoRaWAN technology is using something that is called the ISM band. ISM stands for Industrial, Scientific and Medical Band, which means that everyone can use it free of charge. Okay, so in Europe, it's what we call the 868 megahertz band. So this means that everything that is between 863 megahertz and 870 megahertz, it's free of charge. You can use it. Everyone can use it, operator or not. And that is why LoRaWAN is using these frequencies for their network. I know that some of you were thinking about using the 433 megahertz in Europe, which is also part of the ISM band in Europe. It's not something that the LoRa Alliance really appreciates because it's a low frequency. So it means that the size of the antennas are a little bit bigger, and it's not great for creating small sensors and at the same time putting some huge antennas only because you want to use the 433 megahertz. So our recommendation, and by us I mean the LoRa Alliance, is in Europe to use exclusively the 868 megahertz band because it's the best trade-off between size of the antenna and propagation distances. Okay. Now, of course, it's free. Everyone can use these frequencies. It's free, but this does not mean that you can do whatever you want on these frequencies. So these are unlicensed bands, but it's regulated. So there are two main limitations when using these bands that you have to keep in mind. The first one is that you will be limited to 25 milliwatts of emission power. So if you have a device, it will be limited to 25 milliwatts. Okay, but this limitation is already part of the standard and already part of the radio layer. So you don't have to do anything specific to this. Your device will speak at a maximum of 25 milliwatts, which is, you know, kind of small because most of the mobile phones are using more than 100 milliwatts in emission power. So your device can only communicate at 25 milliwatts, and at the same time it's able to send information more than 15 kilometers away. It's pretty impressive, actually. The second limitation is that you are not allowed to speak all the time, okay, to avoid too much noise or too much interference in these bands. Basically, you have to speak only, you are allowed to speak only 1% of a given time. So if we consider a window of 1 hour, for example, which is basically 3,600 seconds, if I'm not wrong. I hope I'm not. If we take only 1% of this, 6 seconds. So this means that during 1 hour, you are allowed to communicate only during 36 seconds. So you also have to keep in mind this limitation. You are not allowed to send data all the time, 1% of a given time. Now, there is one specific frequency in this spectrum where basically you can use up to 500 milliwatts and 10% duty cycle, but it's mainly used by the gateways. So let's forget about that. Okay. It's not really scope of today's discussion, but if you want to address other regions like US or Asia, the regulations are a little bit different, and the spectrum is also a little bit different. So, but it's not really part of our topic today. But just keep in mind that depending on where you are in the world, the framework, the radio framework is not going to be the same. Okay, so there are some slight modifications, slight adaptations to be included into the design so that it can work absolutely everywhere in the world. Just jumping to another slide. So I see that basically you are not able to see my screen. Okay. Okay, so I will keep it not in full screen. So I hope that now it's a bit better. Okay, check the video streaming. We only see a logo. Okay, is it better now? Can you see the screen normally? Yes, raise your hand. Just joking, I cannot see you, but you can type in a message on the chat. I just want to be sure that I'm not talking. Yes, now it's okay. Okay. You are not able to see this slide. So again, I will quickly explain that limitations in Europe, the spectrum is 868 megahertz. You are allowed only to speak 1% of the time, and you are limited to 25 milliwatts of emission power. So one interesting feature of the LoRaWAN technology is, sorry, this is a little bit technical. It's the spreading factor. Okay, so basically this means that a data through the LoRaWAN network, you can change dynamically the data rate. Okay, so you can use 6 different spreading factors, which means that you can use 6 different data rates. So you can use spreading factor 7, spreading factor 8, 9, 10, 11, and 12. Without entering too much in the technical considerations, when we speak about spreading the data, it means that we add redundancy in the bits of the digital information. So when we are using a spreading factor 7, it means that we are going to replace every bit, so a bit is a 0 or a 1, of the initial message by a sequence of a predefined sequence of 7 bits. So we basically multiply the message by 7 when we use spreading factor 7. The advantage of doing this is that because we are adding redundancy, we are limiting the losses during the propagation. And because we are able to limit the losses during the propagation, it means that we can send the data further away. So basically, the more redundancy we add, so the more we spread the message, the more the more we can increase the communication range. Okay, so at spreading factor 7, we can send the data at a couple of kilometers. But at spreading factor 12, we can send the data very far away, 20 kilometers or more, depending on the propagation conditions. Okay, so again, this is important to understand because the LoRaWAN technology gives the opportunity to the central network server to select for each device in real time and dynamically the best spreading factor. Okay, because if the device is very close to the gateway, you don't need to use spreading factor 12. You can use spreading factor 7, so you can send the data very far away. And the advantage of using a lower spreading factor is that you are going to save on the battery. Because you will use a lower redundancy, it means that you will spend less time to send the data. And because you will spend less time, so less time on air, your device will consume less battery. There is an interesting trade of battery life, data rate, and communication distance. So just to keep things simple, you can see on this slide that if you want to send the data very far away, you need to add a lot of redundancy. So we'll use a spreading factor 12, but in the same time, you will consume more energy, more battery, because the time on air of your signal is going to be higher. So it's not an easy concept to understand. Very powerful feature of the LoRaWAN technology because it allows the network server to dynamically select always the best configuration for the device in order to save the battery. You know, our obsession at Activity, our obsession is always the battery. For us, it's the most important feature that one has to have in the IoT landscape. It's always about battery, battery, battery. Because if in the coming years we are going to deploy billions and billions of connected devices, if we have to recharge or change the battery every other day, it's going to be a failure. So our obsession is really to always optimize the battery life of the devices. So we are very happy that we have this adaptive, what we call adaptive data rate, where we can change the spreading factor of each device so that it really adapts to the configuration. Okay. I know this is a little bit more difficult to understand. If you did not understand anything, just let me know, and I will be happy to spend a little bit more time on this feature. It's probably the most complicated and the most, in the same time, the most powerful feature of the LoRaWAN technology. So I covered the frequencies. Another interesting feature and another important feature of the LoRaWAN technology is that as devices do not speak all the time, you cannot always contact the device remotely, okay? So you have 3 different behaviors for every device in LoRaWAN. So we have what we call class A, class B, and class C. So very quickly, in class A, the device will send the data, like let's say we have a temperature sensor who will send the temperature data, and then once he has sent the data, open up 2 listening slots, okay? So you can use these 2 listening slots to send data to the device. Otherwise, you cannot do anything to contact the device. So basically, in class A, the device has to speak first, and then you can speak to the device. If the device did not speak before, you cannot send information to the device, okay? It's a very important feature. Again, the purpose behind is to save battery, okay? Because when the device is not listening, it's sleeping and it's saving battery. So again, class A means that you cannot send data all the time to the device. You have to wait for the device to wake up, to speak, and then you can send data to the device. Okay, this is the most common configuration for the sensors. I would say that it represents around 80% of the deployed use cases. The second one is called Class B. Class B, it means that the device will wake up for short amounts of times periodically, every 1 minute, every 10 minutes, every 1 hour, and you can use these time slots to send data to the device if necessary. Of course, this is a little bit less interesting from a battery perspective, but it will allow to find the best middle configuration between Class A and Class C. Class C, yeah, I don't have a slide on it, but basically in Class C, the device is always listening. So in Class C, you can contact the device whenever you want. Okay, this is mainly interesting for devices that have a power source, like an important power source, like they are plugged into the electricity network. Okay, for example, lamps. Lamps are always plugged in, so there is no need to save battery for connected lamps. They can use Class C so that you can contact them any when you want. Okay. By the way, speaking about this, one of the most active companies in the LoRa Alliance is a company called FlashNet, and FlashNet has connected streetlights. Okay, and FlashNet is always using the Class C. They are in Romania, by the way, in Brasov, and they are always using Class C for the streetlights. I have a question from someone who is asking me if the spreading factor can be set up by us programmatically, or is it set up by the gateway? So the answer to this is that the spreading factor is managed exclusively by the network server. Okay, and we have a proprietary algorithm that is able to know exactly what is the best spreading factor for the device given the condition of the device, like what is its signal to noise ratio, what is the signal strength, this kind of stuff. Our algorithm is able to define the best spreading factor. So you, as a device developer, you don't have to spend time on optimizing the spreading factor. This is something that is done by the network server. It's completely transparent for you. I hope this answered your question, Mr. Olaru. Sorry about the pronunciation. My Romanian is a little bit rusted. So this allows basically to enable many kind of use cases. I know that all the teams are currently working in use cases for the hackathon next week. Of course, we already deployed dozens and dozens of use cases, so I could spend like 10 hours in explaining all the different use cases that we already deployed in the couple of last years. To say that we have major verticals like agriculture, utilities, smart cities, connected plants. There are many verticals that are currently benefiting from the LoRa technology. I will probably share in the coming days a slide deck on like a top 50 use cases that we deployed, and I hope that it will help you maybe think about other use cases that that you might want to use in the hackathon tomorrow. Sorry, not tomorrow. Next week. Feature is that the LoRaWAN technology is a completely secured technology. So I know that nothing is secure, no technology is perfectly secured, and everything can be hacked and attacked. However, LoRaWAN is probably in the most secured IoT technologies currently available. There are many encryptions at several levels. There is a network encryption between the network server and the device with an AES 128 bits encryption. An application level encryption. So even if someone can intercept the payload, he cannot decrypt it. Okay, he needs a dedicated key to decrypt the data. All the key managements, all the security key managements are handled by the standard, by the MAC layer. So again, as device developers, you don't have to do anything to manage the security. All the security layers are managed by the LoRaWAN standard and by the activity network server. So all the encryption and decryption, all the message integrity check, everything is handled out of the box and completely transparently by our network server. Okay. And don't spend time in thinking about security of your application. Everything is completely secured by several encryption layers. Again, if you want to spend more time discussing this, I would be happy to share all the details on the security levels. Now, one last thing I would like to detail before taking some questions is all the identifiers. And it will be important for you to understand all the identifiers because it's used when you have to activate the device on the activity network server. And not only on the activity network server, because all these are part of the standard. So any kind of LoRaWAN network is using the same keys. Okay, so in LoRaWAN, every device has a unique identifier that is called DEV-EUI. Okay, this is a unique identifier. It's a 64-bit serial number that is completely unique to the device. Okay, during the hackathon, you will be given some dev kits. You will see that every LoRaWAN dev kit has this DEV-UI that you have to keep in mind somewhere because you will need it to provision the dev kit on the network server. This is supposed to be completely unique, so not two devices will have the same identifier in the world. The second important serial number is what we call the dev address or dev ADDR. The device address is like an IP address, so it's not an IP level kind of stuff, but it's like a network address for the device, so that the network server know exactly where to send the data. Okay, the device address is depending on the network. Okay, so several networks can have same dev addresses. It's not an issue because these dev addresses are completely internal to the network. And this is allocated by the network server. Okay, so you don't have to work on the dev address. It's something that is going to be allocated by the network server. The network session keys and the application session keys are two keys that are used for the network level encryption and for the application level encryption. Again, these keys are handled by the network server, and you don't have to work on this. Everything is completely transparent. However, there is another key that is very important. It's called the app key. Okay, the app key is provided by the device manufacturer, and it is used to generate the network session keys and the application session keys. So you will see that when you will have to activate a device on an activity network or any kind of other LoRaWAN network, you have to provide the app key. Okay, because the app key is going to be used by the network server to generate all the network session keys and the application session keys. And the same app key is already inside the device. And the same app key is going to be used to generate inside the device the same network session keys and the same application session keys than on the network server. So that basically all these security keys are never exchanged through the network. Okay, they are generated symmetrically in the same time by the network server and by the device. Okay, so again, it's quite secure. And the app UI, it's not so important, so forget about it. So you will see these keys probably a lot in the coming days and maybe during the hackathon if you choose to use the LoRa technology, because you will have to use them to activate the devices on the LoRaWAN network. Okay. Again, if you have other questions on this, don't hesitate to ask this. And last thing, there are two ways to activate a LoRaWAN device on a LoRaWAN network server. The first one is what it's called activation by personalization. So this means that the device manufacturer needs to give to the network server the device address, the dev UI, the application session key, and the network session key. And someone needs to manually put inside the network server all these keys so that the network server and the device have the same keys and so that they can communicate. Okay, this is not, obviously it's not very secure. It's not used much in production. It's not really used by the big operators. However, it can be used for small events because it allows to quickly activate an object without any more complex activation process. Something more important is the over-the-air activation. The over-the-air activation means that you just need to put the identifier of the device and this major app key, you remember, on the network server, and everything will be generated automatically by the network server and by the device symmetrically. Okay, so this is much more secure. It's much better, and this is the kind of activation that we recommend for most use cases. Sorry, I just realized that I forgot to mention something that is quite important for you to understand, is that in a LoRaWAN network, device is not linked to one specific base station or gateway. It's not like in cellular, there is no synchronization. All the devices in the LoRaWAN technology are broadcasting. So they are just sending their data in the air, and all the base stations, whatever the operator, all the gateways that can hear the data, they will uplink it to the centralized network server. Okay, so this means that potentially the same packet can go through maybe 10 gateways, and the network server will receive 10 packets from the same device. Of course, we have built a deduplication algorithm in the network server, so it's able to detect that the 10 packets are basically the same packet coming from the same device, only going through several gateways, so it will able to dump all the redundant packets. Okay, This is in uplink when the device will send data to a centralized network server. In the other direction, so in downlink, only one gateway is selected by the network server to downlink the data to the device. Okay, so the network server will analyze, will choose what is the best gateway available, given based on radio conditions, availability, and so on. And only one gateway is chosen by the network server to downlink the data to the device. So important to keep in mind, in uplink, we are broadcasting, and in downlink, we are so we are just selecting one gateway to downlink the data. So these are the most messages I wanted to show you, to present. Of course, there are many other technical subtle things in the technology. So I invite you to read the standard, which is available free of charge on the LoRa Alliance website. And should you have any questions, if you need more details, don't hesitate to ask me. I would be more than happy to answer. So now, if you have some questions, I would be happy to answer, either on Slack or on the YouTube channel, as you wish. So I see that some people are typing some questions on Slack. So So someone is asking if there is any format of data to transmit in LoRaWAN networks between the devices and base stations. So everything that happens between the device and the base station is purely LoRa radio layer controlled. So you cannot touch to this. It's completely managed by the LoRa modulation and the LoRa physical and radio layer. So there is no intervention from you on this part. Okay, so it's completely, it's the only, let's say, black box of the LoRaWAN technology. The LoRa, the physical layer, contrary to the network layer, the physical layer is a bit closed and only managed by a company called Semtech. They are manufacturing the LoRa modulation chips, so it's the black box that no one can touch, basically. Another question is, when a LoRa device sends data, does it receive the confirmation that the message reached the server, or we would have to implement that if needed? So yes, the option is available. It's what we call an acknowledgement. So you can choose. It's just a checkbox. You can choose, and you can make your device send data, and every data that you send from your device has to be acknowledged by the network server. This is just a checkbox that you can check on the backend server. So from a technical perspective, yes, you can do it, but again, you have to keep in mind that consume some resources, okay, because you're generating downlinks all the time and you don't have as many gateways in the network as devices. So if all the devices will ask for acknowledgement, it's going to create a lot of messages on the network, so you have to check your capacity. For the hackathon, an issue. So if for the hackathon, if you want to send only messages that need to be acknowledged by the network server, yes, you can do it without any specific implementation. You just need to check a checkbox in the activity backend. Another question is, what about after the base station? Okay, so what happens after the base station is that they are using a classic IP packet structuring. So this is also managed by the MAC layer. So again, you have no control in what's happening between the base station and the network server. Everything is managed by the standard this time. However, the specs of those, so they are in the standard. If you want to know how the packets are structured, it's available in this presentation. This is the way the MAC packets look on the IP network. Of course, you have to add all the IP headers and the IP encapsulation, but this is what packets inside the MAC layer look like. Okay, so this is a little bit more detailed, so I recommend that you read the standard on this, and it will explain all these elements. Otherwise, I will have to spend 1 hour on this. It stops. What stops? What happens to the devices? What happens to the devices that end up their battery lifetime? Someone answered, it stops. It's pretty much this. Yeah, I have nothing better to propose once you don't have any battery left. So it will depend on how you're going to architecture your sensor. You can put usual batteries on it, and if the battery life is over, it's over. You need to change the battery. Or you can put a rechargeable battery system, and you just put it in a USB recharge and so on. Well, the environmental impact is that, well, yes, it's probably better to use rechargeable batteries so that you don't have to throw away the batteries. So my recommendation is to, of course, for the hackathon is to use normal batteries, but in most devices, most production industrial devices, usually we have rechargeable batteries to avoid too much environmental pollution, of course. So maybe I will take a couple of other questions. Yeah, just completing my previous answer to Marius. You don't really need to work on the data format. Okay, you only need to work on your application payload, and it will depend on what kind of sensor you will use. All the rest is taken care of by the network server and by the physical layer. So you just need to work on the physical payload, and this depends really on what kind of sensor you are using and who is the manufacturer. Okay, so this is what we call the application payload. LoRaWAN is not standardizing the application payload, so you can do whatever you want. as you put the right data decoder on your application. Okay, so it's one of the, let's say, issues that we have today with this technology is that we have hundreds of device makers, and every device maker will structure the application payload differently. So we need to implement payload decoders for all these device makers. It takes some time, some resources, but it's the only way to go because LoRaWAN is not standardizing the application payload. So basically everyone does as they wish, as they want. So LoRa payload is not a standard like HTTP format, for example. So again, the LoRa application payload. It's very important to understand that when I'm saying it's not standard, it's only the application part. So the application payload is basically measurement, the GPS coordinates, this kind of stuff. Everything that is used data on the network is standardized. However, the application payload is not standardized. Yeah, so about the link that you copied here, this is pure crap. Sorry, pardon my French. It's pure crap. It's absolutely not true. Again, and I'm not saying this because I work for a company that works on the LoRaWAN technology, pretending that LoRaWAN has an 80% efficiency is a huge lie. And it's said by people who have no general idea about what a LoRaWAN network is. Okay, they are lying because they are promoting their own technology. So again, rest assured, even if it's a pure Aloha system, because we have spreading factors, we have this broadcasting stuff, and at least a 99.0% efficiency. You can easily understand that when you have operators such as Orange, Comcast, or Entity Docomo deploying works, they know that it's not a technology that allows 18% of efficiency. It's a pure lie. Okay, so forget about this. Of course, you will always find people saying on the internet, a lot of trolls, by the way, saying that LoRa is a bad technology with a limited efficiency. Again, this is not true. Okay, of course, you have to keep in mind that there are some capacity topics that you have to take in account. But again, LoRaWAN has, in our experience, and again, we are talking with the biggest operators in the world, at least a 90% efficiency, and you cannot lose packets easily with the LoRaWAN technology. Okay, so again, pay careful attention to what you read on the internet. There are many people that are sending wrong information and wrong messages, either because they have no clue about what they're talking about, or because they just need to promote their own technology. So they are talking bullshit about LoRaWAN. Is there any LoRa DevKit demo project setup? That's a good question. I know that we are going to bring at least 9 dev kits. We can yes, sorry, I will just finish this first question about the dev kit. So we will bring 9 dev kits, 9 LoRaWAN dev kits with us that you will be able to use during the hackathon. And we will provide free accounts to our backend network server so that you can play around in a sandbox production. You can play around with your LoRa technology. So you will be able to provision up to 5 devices by subscriber account free of charge. So I will send you the details on this in the coming days. So yes, this will allow you to, and this will allow you to prepare for the hackathon next week. And again, answering Alex Stefan, nearly all uplink messages are unacknowledged. Again, as I mentioned, this is completely wrong. You can choose or not to acknowledge or not your uplink. We recommend to use this feature carefully, but if you want it, you can choose it. So again, bullshit from Link Labs. I know the guys very well. I know that they are promoting their own proprietary, of course, implementation of the LoRa technology. So of course, their strategy is to talk bullshit about the LoRaWAN technology. Again, keep in mind we have 3 years of experience in this. Of course, Orange and all the biggest operators in the world, they tested this technology. And we can be sure that the guys from Orange and Comcast and all these guys, they are radio experts. So they tested the LoRa technology. They had the right conclusions on the capacity of the technology. So don't worry. Again, I insist, don't worry. It's not what you read on this Link Labs use case. Okay. Okay, I see 2 people typing questions. I will wait for them. Just keep in mind that a base station in the LoRaWAN technology has the capacity to handle several hundreds of thousands of messages per day. Okay, so every gateway is listening all the time on 8 or 16 channels. Keep in mind that most of the LoRaWAN messages have a 55 millisecond time on air. So I let you do the calculation to see how many 50 millisecond messages we can send per day. And you also have to multiply this by 8 or 16 because the gateway is listening on 8 or 16 or even 64 channels for some gateways in the United States. So this will give you a good idea of how many packets gateway base station can handle a day. And again, keep in mind that we are talking about networks where the devices are broadcasting. So several, even if one base station will drop the message because of capacity issues, another one will always uplink the message. All the operators that are currently deploying LoRaWAN networks, they are architecturing the network so that at least 3 or 4 base stations can cover the same geographical point in a country. Connect to your gateway without using the dev kits? Yes, of course, but you have to do everything yourself. So you have to buy a module, a LoRaWAN module, or a LoRaWAN modulation chip. You have to put some firmware on it. You have to downlink firmwares on Git. You have to put it on it. You have to plug in sensors with I2C or SPI or UART interfaces. So you have to do a lot of heavy lifting. I'm not saying it is a bad thing. I'm just saying that we will have 20 or 24 hours. So if you want to on the use case, my recommendation is to use dev kits because this is something that will allow you to be the most quickly, you will be able to up and run the most quickly and to focus on other aspects and not necessarily on the LoRaWAN aspects. But if you already have some other LoRaWAN standard compatible devices, of course, no problem in activating them on our network server. Our network server is compatible with 100% of existing LoRaWAN standard devices on the market. I mean, if you can support with the activation to your gateway, yes. yes, we could support you. Keep in mind that we do not activate on a gateway. We activate on a network server, and several gateways are linked to the network server. So the activation is done on the network server and not on the gateways. Okay, but yes, we can support if you have other devices. I mean, if you want to develop your device, we will not have time to support. But if you already have a device ready and available, we can support you in activating it on the network server. About the 1% duty cycle, this is managed completely by the network server and by the chipset, the LoRaWAN modulation chips. So it's not something that you have to manage. The network server will manage all the available duty cycle capacities per device, per gateway. Okay, so you don't have to manage this. The only thing that you have to avoid is sending data all the time. Okay, if you do this, the network server will detect that will think that you are trying to jam the frequency and will shut down or will eliminate the device from the network. So send the data every minute or every 2 minutes is probably the best way to go in order to avoid any kind of issues with the 1% duty cycle. Okay, so I hope that this answered your question. Don't hesitate to ask me other questions on Slack. I will be happy to answer. And in the meantime, thank you for your attention and have a nice evening. Bye-bye.